Hello, my name is Hunter Adam, and this is my Rubik's Cube presentation. I'm going to start with the outline. We're going to first talk about who the team is, then we're going to go through the problem, and then the proposed solution for that problem, and then some coding and computer vision techniques that I used, as well as the results and some future improvements. So the team was just me. Unfortunately, I was not able to find a team, and so I worked on this by myself. The problem was I have a Python script that reads in a text file that has all of the colors of each side of the Rubik's Cube and then prints out the solution. But the problem with this is that if a user were to use it, they would have to input each side of the Rubik's Cube and their colors and not make any mistakes. So there can't be extra spacing in weird places. There also can't be, if it's red, it can't be red with an apostrophe at the end or some weird thing that might happen. There's a lot of errors that could happen with this. So I wanted to make a way to have the users just take pictures of each side of the Rubik's Cube, and then the computer vision would be used to solve the Rubik's Cube, or to read in all the images, and then the Python script would then solve it. So the proposed solution was to have the user take pictures of each side of the Rubik's Cube. Then the MATLAB script would read in all 6 sides of the Rubik's Cube, then correct any angles or rotations or distortions that the image may have, then grab all the 9 colors from each of the corrected images, format the colors into a text file that the Python script can then read in. Python script would then be run, read in the colors, and then print out the solution to the Rubik's Cube. So in computer vision and coding techniques that I used were, one, image processing. I was able to read in the image, and then I used image interaction like G-input, and then I used corrections such as FitGeoTrans. I also used some color gathering. So from the images, I was able to grab the colors, and then I used color matching so that I could match a color that was close to red. And I also used array manipulation. So I had all of the colors stored in arrays of arrays, so 2D arrays. And then I also had thresholds, and that was to help with color matching. So if a color was close to red, we would match it to red. And then I also used external scripting. So I was able to find a way to run a Python script through the MATLAB terminal. So here are the results of a scrambled Rubik's Cube that was able to be formatted and outputted correctly. So the user would go through, submit their 6 images, and then they would use G-input to grab all 4 corners, or to go all 4 corners of the Rubik's Cube on each side, and that would correct our image. Then the script would run it through it, grab all of the colors of each side, and then it would run the Python script, and the Python script would output this. So R is the rotation of the right side of the face in the clockwise direction, as if you were looking at that right side of the face. So, and then F would be the front face. We have B as back face, B as back face, D as the downward face, U as the top face, and L is the left face. Y is a full rotation of the Rubik's Cube in the clockwise direction, as if you're looking at it from the top down. And then if there's an apostrophe, that we call that a prime. So Y prime would be the counterclockwise rotation of the Rubik's Cube. So using this printed out solution, you can solve a scrambled Rubik's Cube. This was one solution to a scrambled Rubik's Cube, and this is what the Python script printed out. So some achievements are that the user is able to input any scrambled Rubik's Cube and have the solution returned. So no matter what, if it's any 3x3 and it's scrambled, the output will always be the solution to the Rubik's Cube. 2 is after the correction of the images, the program is basically instantaneous. So there's no delay, there's no lag. It is a very quick program to run. We also have a very accurate color correction. So that means that if you take pictures of each side and it notices the white is more like an eggshell white, it's still going to recognize it as white. Or the green is more like a neon green, it's still going to recognize it as green and not another color like blue or red or something else. Also, the program is very easy to use. It's super intuitive. You just put your cursor on the corners of the Rubik's Cube, and that's basically the whole job. Some future improvements that I would like to do would be to get rid of the G input. So get rid of the whole user aspect of it. They shouldn't have to put in the corners of the Rubik's Cube. Instead, I should use computer vision to map out the corners of the Rubik's Cube and correct it myself. Another thing would be to allow the user to input the images without having to name the images left, right, back, front, and so on and so forth. Instead, I want them to just be able to take pictures of the Rubik's Cube, maybe call them 1, 2, 3, 4, 5, and 6, and then the computer vision is able to map out the full 3D image of the Rubik's Cube and then grab the sides how they should be oriented and how they should be corrected. Another thing is that I would like the users to be able to take pictures however they want. So right now you have to have if you're taking a picture of the red face, you have to either take a picture of it with the yellow on top and the white on the bottom, or you have to correct it during the G input phase. So yeah, instead of starting from the top left to the top right, and then bottom left, bottom right, you would then go, like if you were to flip the Rubik's Cube upside down, you would start from the bottom right, then bottom left, top right, top left. So the order in which or the rotation in which you put in the Rubik's Cube does actually matter. And I would like to get rid of that. The last thing would be a better user interface for when the solution is printed out so that it's easier and more intuitive for users to use. Thank you.